All right, hello again. I'm Kevin, back again with yet another CS61B Spring 2018 Midterm 1 walkthrough video. Today we'll be talking about question 4, sans. Implement the methods below. For reference, the int list class is defined at the bottom of the next page. So we kind of remember how int list works. It has a first field and a rest field. That's the most important part. And you can instantiate it with passing in that exactly what you want to be the first and the rest. Okay, so let's take a look at this. So part A asks us to non-destructively create a copy of x that contains no y. And x is this int array, y is a specific integer. So I guess we're going to go through all of x and filter out the y's. Okay, so let's take a look at the structure of this code right now. Let's see. We have an int array x clean equals new int array of that is x dot length. Int c equals 0, and then we're going to loop down through the length of x, do some stuff, probably that filtering that we were mentioning earlier. And then we have an int array r, and then we run a system array copy, and then return r. So I guess if I have a list of maybe 5 elements, and then I try to filter out like 2 of those elements, then that array the resulting array will only be length 3, but we can't know that until we've looped through the entire array. So if we want, we can characterize this as being like, this can be like the filtering step, filter, and store in xclean. So that can be kind of like, that can be kind of like the first step. And then we actually rewrite that filter and store in xclean. And the second part is going to be to copy to correct length, because we won't be using all the space in xclean. Okay, cool. Okay, so now we just need to figure out the logic for filter and store in xclean. Let's see. For int I equals 0, I is less than x dot length, I plus equals 1. So we're kind of just looping through the indices for x. And when we hit each index, maybe we can consider whether it actually should go into xclean. And if so, maybe we can store it using xclean index c and then increment c. So that'll be our plan. So first, we should, like we did in our plan, we should check if x at index I, no, I want lowercase i equals, is it equal to y? I guess we should check if it's not equal to y, right? So if x at index I is not equal to y, then we can copy it over, which will be our filtering process. So if that is the case, then we can store into xclean at index c, xclean at index c equals x at index I to get that value that is not y. Okay. And then because we want to be able to keep on updating c, let's increment c so we can go to the next space in the xclean array. Store at c plus equals 1. Okay, and then for r, we want to copy it to the correct length. So r, we need to create an r that is the correct length. So r should be a new int array of length. Well, if we've been incrementing c all along, then c should ultimately represent the next index where we can place an element, or really the length of the array. So we can just create a new int array for c, and then copy all the elements from xclean, starting index 0, to r, starting at index 0, and we have how many elements? We have c elements. That's the line there. Okay, so that's part A. part B asks us, non-destructively creates a copy of X that contains no Y. And this time X is an int list. So it's called ilsans, int list sans. And we have the same Y. Okay, so looking at this code, I feel like one of them has to be a null case, null checking case. So we just go ahead and do some null check for now at least, see if it works. So if X is null, then we're in trouble. So we got to the end of the list if X is null. So we just return null in that case. Yeah, so useful to notice that this method returns an int list because it's non-destructive. Otherwise, I think this is probably where we do the filtering versus not filtering. So if it is the case that maybe the current item that we're looking at is Y, then we should not include it. Otherwise, we should. And one of them already contains a new keyword for us. So it looks like the second return line, the bottommost return line in part B, that one is the one where we create a new int list, right? So this is where we have to create a new int list and we keep the value that we're looking at. So it should be x dot first. And we want to keep on checking the rest in case there are other things we need to remove, right? So we should make a recursive call on ilsans, passing in x dot rest and y. And what that recursive call will do is it'll say, let's keep on looking at the rest of the list, and it'll perform whatever modification it needs to do on the rest of the list and return the pointer to the front of that list for us. So that means that leaves this case being if x dot first, kind of the same logic as we had earlier. If x dot first is not equal to, or I guess if it is equal to y now, because we want to check if it is equal to y. And if it is equal to y, we should just return what we get from the recursive call, because that recursive call on x dot rest, comma y, will essentially skip over our current element because we're not creating an int list to represent that current element. So it's being forgotten in the result. Okay, so maybe we should do that same idea or something similar for part C. Destructively creates a copy of X that contains no Y. You may not use new. Public static int list still sans. Destructive int list sans. Okay. Do we need a null case? Oh, probably. Let's just go ahead and start with a null case. So again, it's pretty useful to kind of think through these different scenarios and think about what happens when I have the smallest possible list for X, which is nothing, null. And if it is the case that it's null, probably just want to return null. This one seems to be like a little bit less hand-holding because they don't even provide the return statement. Then, okay, so I don't have many spaces to do my destructive part, right? So this problem is destructive, so that should cue us onto doing something that mutates the first and rest and or rest fields. Rest fields of X. And of course, we can't call mu. So that's the only way we can make changes, right? So destructively means that we should mutate the first and or rest fields of X. And that's the kind of thing that we should be thinking about when we see a word like that. Not really sure what's up with creates a copy. I think that's probably a typo in this version of the exam. So just ignore create a copy. Okay, so did a null check. Now, if it's not null, we have at least one thing. So X is at least one element. It has an X dot first, has an X dot rest. And they even provide next case for us. If X dot first equals Y. Right, I feel like we should be doing like that same recursive logic we did in part B, where we called ilsans on the rest and passed in the Y again. Let's see. Wait, but if I want to be destructive, yeah, it should be fine if we do that, right? Because if I have like yeah, it should be fine. Because if I have like an int list like that contains the value 5, and with rest being null, then if I just return ilsans on the rest, that will just be calling we'll be calling dilsans on null, which will just return null, which is our desired result. Okay, so I guess the tricky part then is like, well, how should we do the actual mutation? Because we want to, let's see, if we want to keep it, then we can just return the front. But again, there's that problem of, well, I want to modify the rest, right? How do I keep on doing it on the rest? I definitely need to call dilsans on x.rest and y. So we know that's one part of our code that needs to exist. But I only have one blank to do it, right? Because I need to mutate both x.rest to point to the new result from dilsans, recursive call on dilsans. And then you also need to return it. So this is kind of an interesting challenge because we only have one blank and need to figure out how to fill it in. So I guess in this case, don't really care about x, just need the recursive result. Yeah, so in the case that they provide for us, if x dot first equals y, we don't really care about x, just need recursion. Recursive result. If only I could type. Yeah, so in the first case, where can I fit this in? We'll just put it right here. For the x dot first equals y case, we don't really care about x, just need the recursive result. And then in this case, we do care about x, right? Because we'll be returning that x pointer. Yeah, so we care about x because we need to return x. Because this is going to be non-destructive and we want the first value. We can't create a new int list, so we do need to return x here. But we also still need to recurse, right? But also need to recurse. But also need to recurse. So this is a challenge. We have to be able to do both of these cases together. We know we need to return x on this last line because we need to include that first element that we're currently looking at. We also need to recurse. In the second case, we don't really care about x, just need the recursive result. So if we do, we only have one line, right? So we're going to have to change this line. And I feel like we're going to have to change it to x.rest equals that dilsans recursive call that we mentioned earlier. Dilsans on x.rest and y. Because this is what will be needed to set up the right result for this line. And that's at least making some progress. Now we can try to figure out how can we compose the if x dot first equals y case without breaking things. So if I don't really care about x, I just need the recursive result. Where is that recursive result currently stored? It's actually currently stored in x.rest. So if we could just access x.rest, that will contain our recursive result. I guess you could alternatively make another recursive call to dilsans. But I think this is probably a little bit more efficient because we don't need to recurse down dilsans twice, up down x twice. Okay, so that is problem 4 or 5, sans.